Hey everyone, welcome back. Okay, so here is an example of using k-means. Today we're going to be using k-means to find the perfect Scotch whiskey. This is a pretty fun example, and I can't take credit for it. This was based on a fantastic blog originally written by this author, whom I'm not going to embarrass by trying to say their name. All right. So the idea is this. Single malt Scotch whiskey is a drink that has very specific tastes and flavors per distillery. What I'm going to attempt to do here is use a data set where I have Scotch from 84 different distilleries, classified by 12 taste components, and I'm going to use that data to find groups of Scotch that have taste similar to one another. In particular, one of my favorite Scotches is called Ardbeg, and I'm going to try to find a Scotch that's very similar to Ardbeg. All right. Okay, so let's walk through the code. First, just a little bit of housekeeping. You've normally seen this stuff. What I'm doing here is I'm importing pandas, which I'm going to be using. I'm importing k-means, which is new. You haven't seen that yet. I'm going to be importing the standard scaler. That's because k-means requires scaled input. I'm going to use NumPy, and I'm going to set up matplotlib. Okay. So I have the data stored in whiskeys.txt, and it takes a little bit of cleaning to get whiskeys.txt ready, and I have all that handled here for you. I'm going to take a look at the top of the data frame, just so you can get an understanding of what I'm looking at. So what I have here is, for each of these 84 observations, I have the distillery name, and a rating, I believe, between 0 and 4 or 0 and 5, of the different taste characteristics of the whiskey. So for example, this one has a body of 2, a sweetness of 2, a smokiness of 2, a medicinal taste of 0, a tobacco taste of 0, a honey taste of 2. You get the idea. Lastly, I have a postal code and a latitude and longitude. That's pretty interesting if you would be interested in trying to graph or overlay these distilleries onto a map. I'm not going to do that today, but feel free to do that. And if you are up to that challenge, send me your code. I'd be interested in it. All right. So I'm going to be doing my clustering based only on these 12 variables, and I don't care so much about the distillery name, postcode, latitude, or longitude for my model. So what I'm going to do is I'm going to drop those here. Okay, dropped. And we can see that X is now, for each distillery, only the things I care to cluster on. All right. I'm going to invoke my feature scaler. And then if you were to look at X again, or I'm sorry, X scaled now, you'd see that my X's have been transformed and scaled based on the mean and standard deviation of each column. So they're all on the same scale. Great. Okay. Now this next bit here, I'm going to use this routine to go through and measure the average distortion per cluster for multiple different clusters in the data set. And this is kind of tricky. Don't worry about this. I'm not going to test you on it. All you really have to know is that what this function does is it tries lots of different values of k over the data set, and it will graph each one of them for you. And graph the average distortion per that value of k. I'm going to call that function right here. It's going to take just a second because it's doing quite a bit of computation. All right, it's done. And what you can see is that here's my mean distortion, and here's my value of k. And you can see I called it on values of k from 1 to 9. Okay. So what you see is average distortion is falling quickly, and then I see a bit of an elbow here at 3, another bit here at 4, and then from there on out it kind of goes at a more or less the same scope. All right, so I could choose a K of either 3 or 4, and if I was approaching this from a flat mathematical perspective, I would probably choose 3. But I'm going to choose 4 to start with. Why 4? Well, I have some domain experience with whiskey, and that domain experience tells me that there are 5 Scotch regions in Scotland, and my guess is that each one of those regions would probably have a unique taste. Unfortunately, my data doesn't support 5. It's past all the elbows. So Given there's two elbows in this graph, I'm going to pick the one that more closely conforms to my prior beliefs. Although really you should try both. All right, so now that I know that 4 is the number of clusters I want to work with, what I'm going to do is I'm going to fit a k-means model. K-means model equals k-mean, and I'm defining here the cluster 4. I'm setting my random state so that I get the same output every time. And I'm going to fit x scaled to that model. That just takes a few seconds because my data set's pretty small. And what I can do here, now that I have a fit model, is I can abstract the labels like this. So this is going to give me a label for every one of the 84 data points. And I'm going to set that into my original data frame. Okay, so now if I look back at my original data frame, I can see that I have everything that I had before, but now I also have this label that shows a cluster that each of these scotches is identified with. Now, you remember that I was looking for a replacement or something that tasted a lot like Ardbeg. Well, here's Ardbeg in the data, and it's labeled 2. So what I would care to do is I would care to see which other whiskeys match up to Ardbeg, which are in cluster 2. And so here I just did that. And it's interesting to look at this data, especially in a data set so small, because you can clearly see how close these are related to each other. All of these whiskeys have a large number for body, and a large number for smoky, a large number for medicinal, maybe not so much in tobacco or honey, or they all have about a 2 in spicy. There's one that's a little bit less spicy, one that's a little bit more. More or less, what this has done is this has gone through the data and it's found a bunch of data points that are very similar to each other and have assigned them to a same cluster. This is not very surprising to me because these whiskeys really do paint a pretty good picture of the membership of a particular region of whiskey called Islay. All right, one last thing I'm going to do. If you can imagine these whiskeys, if we were to try to graph this data, it'd be really hard because this exists across 12 different dimensions, right? If we only had body and sweetness, for example, we could plot those against each other as x and y. The problem is that this data exists in 12-dimensional space. I would really like to be able to plot this data, but I can't plot things in 12 dimensions. So I'm going to use some tricky math and machine learning down here that you don't have to really care about, called TS&E. I'm going to use that to show you what these points would look like if we were able to reduce the dimensionality from 12 dimensions down to 3. If you don't really understand what that means, that's okay. I think the visual is worth it. Here's the visual, and what you can see is that each one of these has different colors representing the cluster, and you can see that the four clusters that I've identified here all have different unique colors. So you can see here's a cluster, and then here's another one. The red ones are kind of over here, but there's some weirdness over there. It's kind of hard to see in 3 dimensions, but what I wanted to point out to you is here are the Islay whiskeys that we found. They're off to their own. They're very unique. It's a tight cluster. It's very distinct across all of the whiskeys that we've looked at. And so this is kind of a cool way to visualize that. All right, so that is k-means clustering to help us find and identify a Scotch. I hope you enjoyed that. Thanks a lot for listening, and I'll see you soon.